Hey, welcome to ilectureonline. In this video, we're going to explore the relationship between work and potential energy. Now, in the previous video, we already alluded to the fact that when a force is applied to an object, it will do work as if the object is being displaced by that force. And then that work usually is used to either overcome friction, or it will then, the remaining, if whatever is not used for overcoming friction, the remaining work is then used to give energy to the object, and it can either be potential energy or kinetic energy. So here we're going to look at potential energy. And potential energy is gained by an object if it gains height. And so in this case, we're going to take a block with a mass of 20 kilograms, push it with a force, just enough force to overcome the weight of the block so that we move the block at a uniform velocity without accelerating it to a height of 8 meters. How much work is done, and then how much potential energy have we given to the block. Now, to find out how much work is done, we can use the equation work is equal to force times distance, and of course these are vector quantities, and we have to use a dot product. So this is equal to the force, the magnitude of force, times the magnitude of the displacement, times the cosine of the angle between them. But in this case, since the force is acting in a positive y direction and the displacement is in a positive y direction, the angle between those two are 0, and so we can say in this case this is equal to F times d times the cosine of 0 degrees, which is equal to F times d. Now, how much force is required to move the block upward at a constant speed? That means that the force must be equal to the weight of the object, and so that must be equal to the mg. So we can write here, this is equal to mg, and the distance, the displacement, is equal to the height of the object when we're done, so it would be mgh, and that is the work done to move that block up a height of 8 meters against the force of gravity. So how much energy have we imparted on that block? Well, if none of it is used to overcome friction, and in this case there's no friction anywhere, that means all of that energy was imparted to give it potential energy, or all that work has been imparted to give it potential energy. So in this case, the work is equal to potential energy, which is equal to mgh. So we can see that objects gain potential energy simply by gaining height against gravity. And so we multiply the height times the weight of the object, and that is the potential energy gained by that object. And that's the relationship between work and potential energy. And so to give it a little sense of familiarity, let's plug in the numbers that we have here. We have a mass of 20 kilograms, a height of 8 meters, we know what g is. So in this case, the potential energy gained by that block is equal to the mass of 20 kilograms times g of 9.8 meters per second squared times a height of 8 meters. And so let's see here, here's my calculator. 20 times 9.8 times 8 equals, that's 1,568. 1,568. Now, a kilogram meter per second square is newtons, multiplied times meters, and of course a newton meter is a joule, or that's 1,568 joules of energy imparted onto the object. And assuming that we're doing it really slowly at constant speed, by the time it gets there, it has not gained any speed, so it has not gained any kinetic energy. So all of the work, all 1,568 joules of it, is being converted from work into potential energy.